Hello students, today the agenda is we're going to put a stamp on your homework. We're going to solve some complete squares and your homework or your assignment will be 10.9. So today students will be able to solve quadratic equations of perfect squares. So if we have something like this, remember that when we have a square, it's a perfect square. Why? Because we're talking about that one of the sides of a square would be x plus 3, and then also the other x plus 3. Okay? But how would you solve x plus 3 all to the second power equals to 0? It's similar to the previous lesson. We're going to be taking the square root of both sides. We cancel. Remember that the square root cancels with the square. And so we have left x plus 3 is equals to plus minus 0. Remember that it's always the positive and the negative of whatever comes out of the square root. We subtract 3. And if we have negative 3 plus 0 is going to be negative 3, or negative 3 minus 0 is still going to be negative 3. So you get only one answer for this perfect square. Okay? So that's the first example. Again, this is a perfect square just because we have two of the sides being the same length. And so we take the square root of both sides. And so it's going to be x minus 2 is equals to plus or minus the square root of 9 is 3. We add 2 to both sides to cancel. And so the value of x is equals to, if you need to write this, remember that it means 2 plus minus 3. And so 2 plus 3 would be 5, but then 2 minus 3 would be negative 1. So the answer for x is 5 or negative 1. Okay, for the next example, and if you notice, this is all review of perfect squares, okay? But I want you to get familiar with this part, especially this perfect square, okay? Because it's gonna be useful for the next topic. So this is the part that it's important that we get it to that point. So in here, you're not given the factors already, but we know that this is a perfect square because the first term is a perfect square, the last term is a perfect square, and so we just open parentheses and we take the square root of the first one and put it in here. So the square root of x squared is x, and put it in both of them. The square root of 9 is 3, and put it in both of them. And we keep the sign of the middle term. But remember that we're going to write this with an exponent. So we're going to put x plus 3 to the second power, because we have it twice, equals 0. And that's when we start solving. Okay, so we take the square root of both sides. and x plus 3 is equals to plus minus 0, minus 3 minus 3, and this cancels, so my x is equals to, again, when you add 0 or subtract 0 from something, you will get that same answer, okay? Because you're adding 0, it doesn't change this. And if you subtract 0 from negative 3, it doesn't change either. So it's just x equals negative 3. So again, you get only one answer when you're adding or subtracting 0. Only one answer. And again, if you want to, I just want to remind you that later on we're gonna be relating it to the x-intercepts. So that means that this equation intersects only at one point, okay? At one point, instead of going like that at 2 points. Okay, the next one is x squared plus 6x plus 9. And perfect square. Whoops, I just copied the last one. I'm so sorry. So it's, let me cross that out. So the next example is x squared plus 8x plus 16 equals 0. And so again, this is a perfect square, this is a perfect square. And so I open my parentheses. Perfect square. In fact, I can immediately just get rid of one of the parentheses and know that it's x, the square root of 16 is 4, and just put a square in there. You can do that too. You can go directly to the perfect square already, meaning that you would go directly to this step, okay? And then just put it that you have it twice. How do we solve this now? Just like with the first two examples and previous lessons, we take the square root of both sides. X plus 4 is equals to plus minus 0. And we subtract 4 from both sides. This cancels, and x is equals to, again, if we're adding and subtracting 0, we're just gonna get one answer. It affects only when we are adding or subtracting a different number that is not 0. Okay, only one answer. My parabola for this equation will cross only in one place, the x-axis. Okay. X squared plus 14x plus 49 equals 4. So something different. Let me go back to the previous ones, and I want you to see something before I move on to that one. I want you to notice that this number is half of the middle term. For number, actually this was supposed to be number 4. For number 3, again, this number is half of the middle term. Okay, and maybe, I mean, that's going to be important later on for the next topic, but I just want you to start looking at that. So what do you think the number in here is going to be? If you want, you can do the 2 parentheses, or you can just put square, it doesn't matter. Let me do it with the 2 parentheses. Perfect square. There are two relationships to both of these. To find this number, it's going to be the square root of this one, but we can also find it by taking half of this. And that's only when we have a perfect square, okay? When we have these two perfect squares on the out terms. So it's going to be x, and if we look at this one, it's going to be half of it, which is plus 7, or you can also find it by taking the square root of 49, which is the square root of 49 is 7. Okay, we write it as a square, which you could have done directly if you wanted to, and we proceed to solve. So take the square root of both sides. X plus 7 is equals to plus minus the square root of 4 is 2. We subtract 7 from both sides. This cancels. And this is the instance when you get two different answers. Because negative 7 plus 2, negative 5. Or negative 7 minus 2, that's negative 9. So this is the two places where my parabola will intersect the x-axis. If you need to see this work, remember that you just write the negative 7 first, and then plus minus 2, you can do plus 2, and then negative 7 minus 2. Okay, so you can do that on the side if you get confused doing it directly, the both paths. So negative 7 plus 2, different signs, we subtract and leave the sign of the greater one. Same signs, we add and keep the greater sign. So negative 5, negative 9. Okay. Oh, and this was exercise 5, and the previous one was 4. Sorry about that. Okay, in here, I'm going to be giving you a perfect square, but in addition to that, we're going to be subtracting 9. And that's going to be equals to 0. Before we can solve any of these, we're going to get rid of these 9 by adding 9. So they cancel. And so I'm going to have this perfect square, which is x plus 3 to the second power, because I haven't canceled that, is equals to 0 plus 9, 9. Now I can get rid of the square, and the opposite of the square is square root. I do that to both sides. And so I get x plus 3 is equals to plus or minus 3. I subtract this 3 from both sides. And so x is equals to negative 3 plus 3, that's 0. Or negative 3 minus 3, that's negative 6. Again, you can do it on the side, negative 3 plus 3 and negative 3 minus 3. And you can see that these cancel each other because they're inverse of addition. So that's 0. And addition of negatives, so that's negative 6. Okay, one more example. And so we have x plus 4 all to the second power minus 5 equals 10. So I'm going to get rid of this first by adding 5. And so I have left my x plus 4 to the second power, because I haven't canceled that, equals 15. I take the square root of both sides to start canceling this side and leave x by itself. So x is going to be equals to, oops, I haven't gotten rid of the 4. So x plus 4 is equals to 15 is not a perfect square, so I cannot simplify it. I'm going to put plus minus the square root of 15. We subtract 4 from both sides, and so x is equals to, since I cannot combine this because this is an irrational number and this is an integer, I'm just going to bring down the negative 4 and I'm going to bring down the plus minus square root of 15. And so that's going to be my answer, okay? Again, in the future, we're going to be taking the square root of this with the calculator so that we can graph, but for now, this is the answer. So now you can start working, after seeing these examples, you can start working on 10.9, and I hope this was helpful.